My name is Elivan Aminun with metric number C200162, and now I will explain the experiment 1 in lab 2, which is computation of line parameter using MATLAB. So in exercise 1, we have manual calculation. So you can see here the conductor radius is D equal to 1.345 inch. So our R equal to 1.345 over 2. So the answer is over 12 because inch to feet equal to inch over 12. So we get the value of R is 0.056 feet. So that's all for GMRC. For GMRL, we get the value is 0.0444 feet. And we also calculate the GMD. So the answer of GMD equal to 44.097 feet. Other than that, we also calculate the inductance per phase. So L equal to 0.2 and 44.097 over 0.0 for 1044. So we get the value of L equal to 1.3802 mH per km. We also calculate the value of capacitance per phase. So our value is 0.0083 mF per km. So this is our program in exercise 1 given in lab sheet. So we have 4 inputs, which is DAB, DBC, DCA, and GMRL. And for GMD, the formula is given. Also the L and C. So after that, we try to run the circuit. After we run the program, we have to enter the DAB value. The value of DAB is 35. Enter the DBC value. DBC value is 35. For DAC is 70. We also enter the GMRL value. So our GMRL value is 0.0444. And enter the diameter. Our diameter is 1.3450. So we can see here the value of inductance is 1.3802, and for the capacitor value is 0.0088. So we compare the value in simulation and the manual calculation. So this is the manual calculation value, which is for L is 1.3802, for capacitor is 0.0083. So we can see here the value simulation and the manual calculation for induction and capacitor is same. So that's all for me, and
Assalamualaikum and a very good day. My name is Ismail bin Muhammad Abdul Wahab and my matrix number is CE200111. I am presenting group 1 for Power System Laboratory 2 for exercise number 2. So this is the task for exercise 2, and first I would like to show the manual calculation. First, we need to find the radius, which is equals to 0.4885 inch, and then we find the GMD, which is equals to 44.0972 feet, and next we find the GMRL, which is equals to 0.2215 feet, and last we find GMRC, which is equals to 0.2471 feet. And from what we get, we can calculate the inductance per phase, which is equals to 1.0587 millihenry per km, and then is the capacitance per phase, which is equals to 0.0107 microfarad per km. Next, I would like to show the simulation. We will be using MATLAB software for the simulation, and this is our coding. So this part is for the input value, and this part is for the formula, and last part is the output. Okay, Let's run this simulation. First, we need to enter DAB value. So DAB is from here to here, which is 35 inch. And next is DBC value, which is from here to here, also 35 inch. And then is DAC value from here to here, which is equals to 70. And the conductor diameter in inch from the task we get is 0.977 inch. And the bundle spacing from the task is 18 inch. Last is the GMR value in inch is 0.3924. So as you can see here, this is the value of inductance in millihenry per km get is 1.0588, and if you compare to the calculation, which is 1.0587, it's fairly near. And for the value of capacitance in microfarad per kilometer is 0.0107, and in the calculation get is also exactly the same, 0.0107 microfarad per kilometer. Okay, that's all from me for exercise number 2.
Assalamualaikum and greetings to Dr. Abu Ubaidah. So my name is Ahmad Qayyum bin Ahmad Jan, and my matrix number is A190012, and I'm from group number 1. Okay, so for our power system lab, for lab 2, which is the title is about the computation of line parameters. Okay, so I am in charge in doing the exercise 3. Okay, so as you can see, this is the like sheet of the experiment. Okay, and this is the given MATLAB coding for the exercise 3. Okay, you can see here. Okay, so now we open the MATLAB software. Okay, so I have input the given coding in the lab sheet, and I have arranged it properly so that it won't be very messy. Okay, so the total number of the coding is about up until the line 54. Okay, so now I'm going to run the whole coding. Okay, so we go to run, we proceed to run, press run, and then add to part. Okay, you can see at the command window below, it will pop up instruction asking for the user to input the value for the row vector. Okay, so just enter any value. Okay, so I will enter 11. I'm sorry. Um, 11, 12, and then 13. And then close the square bracket, and then you enter input. Okay, and then it will second command will come will pop up and asking to enter the value again. Any two value. Okay, just enter the value. So for this one, I will enter 21 and then 23. Sorry, I forgot the square bracket. Okay, and then close the square bracket, and then your input. And then it will ask the bundle spacing dimension in inch, and then just enter for this one I will input 16, and then the fourth command will pop up and asking the user to enter the conductor diameter in inch, and then just input 17, and the last one is the geometric mean radians in inch. Also for this one I input 10. Okay, and so after you have input the geometric mean radians in inch, it will automatically calculate the value of GMD, and then the value of GMRL, and then L, and then also the C. Okay, as you can see here, the GMD value that we get based on the input that I have an input just now. I get GMD as 29.1057, and for the GMRL I get 1.9613. As for the GMRC I get 1.8832, and for the L I get 0.5395, and C is 0.0203. Okay. The value of this value will be automatically calculated based on the formula that we have set inside the coding. So that's all from me for the exercise 3. Thank you.